Okay, day 2, all the steps are done. And so now we'll get the platform done. Still haven't got the bench, so still having to do it on the trestles. But I thought that might be interesting to show how to get something completely level and flat even though you haven't got a completely flat surface. Okay, so for now I've just laid the steel on top of some offcuts straight on top of the trestles. And what I'll be doing is using a spirit level to get everything flat this way, get everything flat that way. These offcuts are very flat and straight and strong, so what I will actually probably do is clamp with some rigid clamps onto those, but also on the corners I've got these flat pieces of steel, and if I clamp those together that will also bring everything nice and flush also. And to make sure everything is square, I'll measure corner to corner to make sure the diagonals are exactly the same, which means it'll be absolutely square then. And obviously making sure that the steel is cut to the correct size, which it is, and measuring it from the outside then, make sure that's the same back here as well also. That's what I'll be doing. So you can see here, I've made it pretty level on that plane, and because I've clamped this to that extent, it's actually lifted off this side, and it's still pretty flat, which goes to show how effective clamping those corners is. But what I will do is put some packers under there anyway, just to make sure it's okay. Okay, so everything's now level, it's all flat. But what I need to do is to make it square. So I need to first of all make sure this distance here is exactly the same as this distance here. So what I'll be doing is I'll take a measurement and I'll tap it either way using a hammer, and then I'll clamp this bit of flat bar on, and that should hold it completely steady. That will be then held at the exact same distance that is as this. And then what I'll do is check the diagonals and tap it accordingly until it's all completely square, and then I'll check levels again after. I don't know if I'm explaining very well what I'm doing, but if I try and do a quick analogy here. Not very well constructed, but essentially we're creating a square, or a rectangle, but we want it to be square, as in exactly 90 degrees on either corner. So the way we do that is we measure from the diagonals. Now the problem is it's more like that. It's like a diamond. That's obviously exaggerated, but to give you a perspective, it's shorter here than it is here, and that's the same here. It's long here but shorter here. So what we want to do is knock this corner that diagonally to make it become square. So what I've done is by tacking, making sure these distances here are exactly the same. By putting little tacks, it'll actually pivot on those tacks like that, ever so slightly. There's a little bit of movement, but not too much. If you overdo it, obviously the tacks will break and it won't work. But for this, I'm going to simply hit that corner and that should make it square. I'm going to weld the outside faces first, and then I'll weld the inside faces after. And so I decided to go from the inside out, and I did that the exact same way on both sides. So the direction you travel, there's going to be contraction, so everything will want to move like that as you're welding. So doing it equally the same on both sides, you should get equal opposing forces, keeping everything nice and square. Whilst if I went this way, that side, but from the other side came the exact same way facing this way, everything's pulling that way, so it would bring it all out of alignment. But hopefully you won't get any of that because everything's strengthened by all the bracing. So now that I've got one face welded, I'm going to measure up the diagonals one more time, just to see if there has been any movement. That's pretty much bang on. So I'm confident with my clamping now. What I'll do is I'm going to flip this over and weld the same on the underside, and then I'll put it on its end and weld the inside. Okay, so I've flipped it back over onto the flat. I've measured it up. It's still completely square. It's also completely flat. I've put a couple of shims under just to make sure everything was flat, and everything is. So now on the drawing, I've got the rest of the cross members to do, and I know that there's a gap in between each one of about 80 millimeters. So rather than measuring and marking, what I'm going to do is cut a piece of the offcut to 80 millimeters, and I'm going to clamp that on. And that will mean that it will be 80 millimeters apart, and it'll be quick to reproduce as well using the same spacer. So I'm going to cut one of those on the saw and start welding that up. Okay, so that's that part done. There's still a few more bits I need to put on it. But you might have noticed me looking at this, which for a better word is bowed to hell. And that's because the welds here have contracted and actually really pulled in the material so much that it's contracted by about 1 millimeter, and that is equated to this flat bar bowing out ever so slightly, giving under the pressure. So to stop that from happening, what you could do is put another bar, a thick one like this, maybe 1/2 mil bigger than this gap, and then by the time this wants to pull in, it's prevented and will actually contract back to being perfectly level. So that's what I've done before on bigger bits of machinery. I should have really thought about it really. But you know, I'm getting stuff within 1/2 millimeter, 1/4 millimeter, and it doesn't need to be. There is actually a tolerance of probably 1 millimetre either side, so 2 mil. But I like to make things as accurate as I can if I can. Okay, next part.